By the way, thank you so much for designing this t-shirt for me. Thank you. Right? So this right here, you will remind me that, you know, I'm staying strong. We can kick calculus in its head. Okay? Now, number 15. This is a tough one. I still put it here. I really don't know why. Maybe I should change it, but it's too late now. 1 over x cubed plus 1. Yes, you are seeing this right. Integrating 1 over x cubed plus 1. Yes, we have to factor the denominator and we have to do some partial fraction, the dirty work, right? When you factor the denominator, you are going to get x plus 1 times x squared minus x plus 1. So let's see. Perhaps I'll put the final answer right here. So I will do the partial fraction right here in blue for you guys. First of all, I will just be writing this down as 1 over x plus 1 times x squared minus x plus 1. We have two factors. The first one is linear, so I'm going to say this is equal to some constant a over that denominator, which is x plus 1, and then the other one I'll also say plus. This guy is irreducible quadratic. Therefore, on the top, we have to set out linear. In another word, we have to put down bx plus c. All right, a it's easy to figure out because we can do the cover up method. I'm going to go to the original denominator, cover this up, and I will ask myself, what do I need to put in to make this 0? I need to put in x equal -1. Putting -1 here. Check this out. -1 squared is 1. -1 is another 1, so I have 2, and then plus 1 is 3. So, yeah, that's it. 1/3. A is equal to positive 1/3. That is very nice. And we also have to figure out the B and then C. Well, the deal is that we can just plug in whatever x values that we want now. But let me just make a note. We used x being -1 to figure out A, so we cannot use -1 anymore. But we can now use, let's say x is equal to 0. We're going to do this in our head, okay? When you're putting x equal to 0, this right here, we cannot cover anything up, so you put x equal to 0 for all the x. On the left-hand side, this is 0, this is 0, this is 0, 1 over 1 times 1, so you have 1. And on the right-hand side, this is 0, so 1/3 divided by 0, so you have 1/3. Well, the beauty of putting 0 is that you see b times x, in another word, b times 0, this is gone. So this is gone. So 0, 0, so it's 1 on the bottom, so you get plus c. That's what we have. In another word, you see that c is equal to minus the 1/3 on both sides. You get positive 2/3 for that, so that's very nice. Okay? And to figure out b, well, we use 0 and -1 already. Let's pick another easy number. Let's say positive 1. Why not, right? So now I will just say use x equal 1. Plugging 1 into all the x, not cover anything up, okay? So you get 1 over, let's see, do this carefully. 1 plus 1 is 2. Yes, you heard me right. 1 plus 1 is 2, I said that. Anyway, putting 1 in here, 1 squared is 1, minus 1 is 0, and you have just 1, so you have that. So it's pretty much 1 over 2 on the left-hand side. Still not that bad. Now, putting 1 in here, you have 1 over 3 divided by 2. In another way, you have 1 over 6. Putting 1 in here, so you have b on the top. And then you have plus c is 2/3 over. And then if you're putting 1 in here, 1 minus 1 is 0. So you have over 1. So in another word, this doesn't matter. So you just have this. And then you can just solve this little equation now. That should remind you of the good old algebra days. You can just solve this and you get everything right. That's the whole question, right? Okay, let's see. What can we do? What to do fractions? Multiply this by 2, multiply this by 2, so you get 4 over 6, right? So altogether, this is 5 over 6 plus b. And on the left-hand side, of course, this is 3 over 6 minus 5 over 6 on both sides. b is equal to negative 2 over 6. In another word, negative 1/3. So b is negative 1/3, like that. Okay? Anyway, that's the partial fraction part, and I'm going to erase this, and I will be looking at the integral now. So we'll see, we will have to integrate the following. This right here is the same as integrating this and that. So I will just write this down right here for you guys. Integrating 1/3, let's just put that down right here in the front. And then we have the 1 over x plus 1 like this. And then let's close this integral, why not? And then for the second one, I will just write it as plus. And in fact, I will just keep them as how they are. So perhaps I'll write down, we have the, well, both of them have the third. I can factor that out, right? So perhaps I'll factor that out. And I have to do this carefully because I've been doing like 15 integrals already. So we'll see. It's not that bad. Thank God I didn't put this until like the 95th integral. Otherwise, I don't know what will happen. Anyway, integrating. I put a negative 1/3 in the front, okay? I factor out the negative. So the b right here is, this right here is just going to be x. And then this right here is going to be a minus because I factor out negative, so it's going to be a 2. And then the bottom will stay the same, x squared minus x plus 1. Like that, right? Oh, I should put this down in blue. Let me just do it real quick. X minus 2 over x squared minus x plus 1. Okay, we're going to look at this slightly more carefully. Notice, I will just put this down for you guys. That was easy, by the way. So look at this. Notice, if you differentiate x squared minus x plus 1, you get 2x minus 1. On the top, I don't have 2x minus 1, unfortunately. I have x minus 2. I'm going to somehow manufacture the 2x minus 1 to help us out, and this is how we can do it. I will do this. Actually, I'll put this down in black. Let me actually put this down in black. Sorry. Yeah. Again, x minus 2 over x squared minus x plus 1. This is serious now. I want to have a 2x minus 1 on the top to help me out. This is how. Well, I'm going to multiply the top by 2. Of course, if I do that, change the whole thing. It's okay, I can just divide the 2 in the front, like that. So that's still legit. And if you look at this right here, it's going to be 2x minus 4, right? But I want to see a 2x minus 1. So it's okay though, we can just look at this as 2x minus 1, and then minus 3, like that. And there's the reason why I want to do this. So let's see, I'm not going to integrate this yet. I'm just going to write this down again, and then I will do all the integration at the very end. The first one stays the same, and then the next one will have minus, you multiply, you get 1 over 6, integral, I'll put parentheses. Here's the deal. I will pair this with this denominator, which is 2x minus 1 over x squared minus x plus 1. And I'll close that. And then I'm going to minus, this is still minus inside, okay? So I'm going to minus the integral 3 over. Here's the deal. In order for me to do this, I will have to complete the square for that. So let's see, what's the complete the square for this? I wish to have minus 2, right? So I will have to minus 2 here, minus another x here, and then plus x. What did I say? No, I cannot do that. That's the forced power situation. Okay, here's the deal. X squared minus x. To complete the square right here, I look at half of the coefficient of x, which is negative 1. And half of that is negative 1/2. You are going to square that, and that's the magic number. So I will look at this as plus 1 over 4, right? But originally I have 1, so I need plus 3 over 4. And as I said, this and that is still the same, and that will give us a perfect square. And the perfect square is going to be x minus 1/2 square, like that, okay? And perhaps I'll erase this right here now, because I don't need it. And right here, we have plus 3 over 4, and this is what I will do. I will say plus, I need to look at this in the 1 over like u squared plus a squared. So you can put a 3 in the front. So I'm going to look at the 3 over 4 as square root of 3 square, but we'll also have the denominator, so let's put down this over 2, and then we'll have that being squared like that, dx. Whew. Yeah. Okay, finally, let's integrate. This right here, easy. 1/3 natural log absolute value x plus 1. Done. Right? Done. Write this down better. Okay, minus 1 over 6 times this. And the beauty of this is that the derivative of the bottom is exactly on the top. So this right here will give us precisely natural log of the denominator, which is x squared minus x plus 1. And the truth is, if you see the denominator, which you can complete the square right here, you're always going to get positive. So in other words, you can just put down parentheses for this. And I put 1 over 6 times this already, so we are good. Now, negative times negative will give us positive. And then 3 over 6 is 1/2, okay? So this is 3 over 6. That's how we get 1/2, okay? And of course, negative times negative positive. Here is a small trouble part. You're going to end up with the inverse tangent part. So you are going to do the reciprocal of this first. Namely, you multiply it by 2 over square root of 3, and then the inverse tangent. And the input is going to be this as your u. And thank God, the derivative of this is just going to be 1, so that's good. So you put this down, which is x minus 1/2. And then you divide it by this guy, which is the square root of 3 over 2, like this. That's pretty much it. But I will simplify this a little bit for you guys. Right? So we have just 1 over square root of 3 right here. So I will just write this down again. Here we have it. 1/3 natural log absolute value of x plus 1 minus 1 over 6 natural log parentheses x squared minus x plus 1. This right here plus 1 over square root of 3, like this. Okay, so let's just write it down like this, okay? Inverse tangent, and I'll put this as the reciprocal, namely 2 over square root of 3. We're okay with this, and then I'm not going to distribute it. Please don't make me distribute this. You can, but let's just do it. So you have this times x, right? So you have this times x, you have the 2 over square root of 3 times x, and then the 2 and that 2 will cancel each other out. So you will have minus 1 over square root of 3, like that. Yes, I think this is correct. All right, well done. Don't forget to put a plus c. If you don't put a plus c, that will suck. So don't forget to do that. Don't forget to do that.